I agree with you here. M squared minus n squared equals 1 would be sort of implying that there were two squares that were 1 apart from each other. But that really doesn't happen except for 0 and 1, but 0 is not a positive integer. So it doesn't seem like this one's true to me. Let's try to approach it with your idea there. Let's try to go by contradiction. And it is in the contradiction chapter. So, proof. Okay, for contradiction, suppose m and n are positive integers with m squared minus n squared equals to 1. Okay, by the difference of squares formula, this would imply that this factors down into, or this doesn't imply that it factors, but it does factor down into m plus n times n minus n. So we would have m plus n times m minus n equals 1. All right? But m and n were positive integers, so m plus n is also a positive integer. M minus n is an integer also, potentially negative, but really the point here is that they have to multiply together to become 1. There isn't a lot of integers that multiply together to be 1. In fact, there's only 1 times 1 and negative 1 times negative 1. So m plus n would have to be equal to either 1 or m plus n would have to be equal to negative 1. And then m minus n would be negative 1 and m plus n would be, or m minus n would be 1 over in this case. But neither of these are possible. Since m and n are positive integers, they are both bigger than or equal to 1. So m plus n is bigger than or equal to 2. So m plus n cannot be either 1 or negative 1. Neither of those are a possibility. So this is a contradiction. Right? It's a contradiction because we have that m plus n equals 1 or m plus n equals negative 1. But we also have that m plus n is bigger than or equal to 2. And this contradiction proves our claim. So we get to conclude it with an MWO.